In the vast, unyielding silence of interstellar space, where stars whisper secrets across eons, a lone wanderer pierced the veil of our solar system on July 1st, 2025. Discovered by the vigilant eye of NASA's Atlas telescope in the crisp Chilean night of Rio Hurtado, this intruder, designated 3I/ATLAS, hurtled toward us at over 60 kilometers per second, faster than any native comet dares to dream. It was no ordinary rock, no familiar icy relic from our own cosmic backyard. This was the third confirmed interstellar object to grace our skies, a messenger from beyond the Milky Way's frayed edges, carrying the faint frozen echoes of a distant star's forgotten nursery. But as telescopes worldwide turned their gaze upon it, something stirred in the data, a subtle defiance of gravity, a shimmer of chemistry too precise, too alien. What if this visitor wasn't just passing through? What if it was watching us back? Tonight we unravel the thread of 3I/ATLAS, from its breathtaking arrival to the anomalies that have left astronomers staring at screens in quiet dread, questioning not just the stars, but the very fabric of reality itself. Imagine the moment of detection, a faint smudge on a digital plate, magnitude 17, barely a ghost against the star field, flagged by Atlas's automated algorithms. Pre-discovery images, pulled from archives like hidden diaries, stretch back to June 14th, revealing the comet's quiet approach. By July 2nd, the Minor Planet Center had christened it C/2025N1, Atlas, but the 3I prefix sealed its otherworldly status. Interstellar, the third in a lineage that began with Oumuamua's enigmatic tumble in 2017 and Borisov's gaseous sigh in 2019. Unlike its predecessors, 3I/ATLAS announced itself with a coma, a hazy envelope of gas and dust cloaking its nucleus, proof of sublimating ices heated by our distant sun. NASA's Hubble Space Telescope, ever the sharp-eyed sentinel, captured its first portrait on July 21st, when the object was 277 million miles from Earth. There, in infrared clarity, lay a nucleus no smaller than 440 meters across, potentially swelling to 5.6 kilometers. Vast, shadowy, and improbably intact after billions of years adrift in the void. Yet even in those early frames, unease rippled through observatories from Mauna Kea to Cerro Pachon. Ground-based scopes like the Canada-France-Hawaii Telescope and Lowell Discovery Telescope detected a marginal tail, a mere 3 arcseconds of elongation, but its direction whispered heresy. Comets, those predictable performers, unfurl tails that bow away from the sun, sculpted by solar wind and radiation pressure into elegant anti-sunward arcs. 3I/ATLAS's faint extension hinted at something reversed, a counterflow, as if the object were exhaling toward the light rather than fleeing it. "Physically absurd," murmured one spectroscopist at the European Southern Observatory, his voice echoing in a control room thick with the hum of cooling systems. According to preliminary trajectory models from NASA's Jet Propulsion Laboratory, the comet's inbound velocity suggested a mass far heavier than its dim glow implied. It moved with the lethargy of a behemoth, yet reflected light like a feather, lighter than it should be, by factors that gnawed at equations etched in chalkboards decades old. As August dawned, the James Webb Space Telescope joined the vigil, its golden mirror tilting skyward on August 6th to train the near-infrared spectrograph on this cosmic outlier. Webb's gaze pierced the veil, unveiling a composition that defied the solar system's alchemical palette. Carbon dioxide dominated the coma, not as a trace but as a sovereign, levels 10 times higher than in Borisov, suggesting a nucleus rich in CO2 ices that sublimate at frigid distances, as far out as 6.4 astronomical units, per NASA's Transiting Exoplanet Survey satellite data from May 2025. Water vapor mingled there too, alongside carbon monoxide and the sulfurous tang of carbonyl sulfide, but their real shock lurked in the metals. Nickel, vaporized and unbound, flooding the plume in quantities unseen in any comet before. Iron, that steadfast companion in solar system ices, was all but absent. An elemental imbalance that evoked not the gentle forge of stellar nurseries, but the harsh precision of a lab. It's as if the comet has been refined, noted a researcher from the Instituto de Astrofísica in Chile, her fingers tracing spectral lines on a glowing monitor. Webb's hyperspectral maps revealed no ordinary crust. The surface bore scars of cosmic ray bombardment, billions of years' worth, transforming pristine ices into a hardened shell that scattered light in blue-tinged defiance. This blue hue, unusual, almost defiant, emerged as a recurring specter. Early Hubble images painted 3I/ATLAS in neutral tones, but by late August, Gemini South's multi-object spectrograph caught a shift, a subtle azure bloom, as if the object were absorbing red wavelengths and exhaling the rest. Comets redden with age, their surfaces baked to rusty patinas by solar onslaughts, but 3I/ATLAS blued further, its albedo climbing unexpectedly. According to models from Michigan State University's Daryl Seligman, this could stem from exotic volatiles, perhaps nitrogen-rich ices, rare even in the Kuiper Belt, or something more profound, a surface engineered to reflect, to signal. The Vera C. Rubin Observatory, in its science validation phase, serendipitously imaged the comet from June 21st to July 3rd, noting a coma diameter swelling by 20% in weeks, yet no corresponding outburst. Stability where chaos should reign. Rotation, too, puzzled. A leisurely 16-hour tumble, too slow for a fragile ice ball to endure without fracturing, yet the nucleus held, unyielding. Enter Avi Loeb, Harvard's unyielding astrophysicist, whose voice cut through the murmurs like a laser through fog. Fresh from his Galileo project's hunt for extraterrestrial artifacts, Loeb had long argued that Oumuamua's non-gravitational acceleration, a gentle 4.9 times 10 to the negative 6 meters per second squared nudge, unexplained by outgassing, warranted scrutiny beyond the natural. For 3I/ATLAS, he saw echoes, an inbound path aligned too neatly with the ecliptic plane, improbable for a random ejecta from galactic tides. In a July 16th arc of preprint co-authored with the Initiative for Interstellar Studies, Loeb posited anomalies stacking like storm clouds, size exceeding 5 kilometers, a minimum mass of 33 billion tons, 3 to 6 orders heavier than Oumuamua or Borisov, chemical sparsity in the coma, and that ecliptic fidelity, as if guided rather than hurled. The odds of natural origins for all these traits converging? Astronomically low, Loeb stated in a Medium essay on July 2nd, his words rippling across academic forums and social feeds alike. He unveiled the Loeb scale, not the Torino's threat meter, but a 0 to 10 gauge of extraterrestrial probability. Level 0 for mundane rocks like Borisov, level 10 for confirmed tech with global peril. 3I/ATLAS ? He slotted it at level 4. Multiple persistent oddities, no tidy natural alibi after rigorous vetting, a 40% whisper of techno-signature, enough to quicken pulses in SETI labs from California to Chile. The scientific chorus pushed back, voices measured but firm. NASA's planetary defense protocols activated not from fear, but precaution. The International Asteroid Warning Network coordinating data flows as 3I/ATLAS barreled inward. Extraordinary claims demand extraordinary evidence, cautioned ESA's Marco Micheli, who refined the trajectory for Webb's pinpoint capture. Yet doubt festered. Simulations from the Space Telescope Science Institute projected a perihelion on October 30th, 2025, at 1.4 astronomical units, inside Mars' orbit, 210 million kilometers from the Sun, where solar heat should unleash a maelstrom. TESS's pre-covery data hinted at activity months prior, CO2 and CO sublimating at low temperatures, priming the comet for volatility. But as September waned, Keck 2 on Mauna Kea unveiled a plume laced with nickel carbonyls, a compound birthed not in stars but factories on Earth. Iron's absence screamed imbalance. Nickel's abundance evoked metallic hearts, perhaps a core forged in a supernova's fury, or something deliberate. This isn't just chemistry, Seligman told a virtual symposium on September 25th. It's a window to a planetary system we may never visit, a relic transformed by radiation into something other. October brought the hush. Solar conjunction swallowed 3I/ATLAS on October 21st. The sun's glare eclipsing it from Earth's view for weeks, a cosmic intermission thick with anticipation. Funding hiccups at NASA delayed some feeds. ESA's embargo on raw Mars orbiter data fueled whispers of containment. ExoMars trace gas orbiter snapped a streaked silhouette on October 3rd, the comet a blur against Martian stars, its coma glowing faintly. Mars Express trailed suit, detecting water loss, like a fire hose per preliminary logs, hundreds of tons vaporized daily. Yet simulations darkened. The outbound path veered toward Jupiter's realm, grazing no moons but threading perilously near ESA's JWST probe and NASA's Europa Clipper, both en route to the gas giant's icy kin. Ion tails could snag instruments, sampling exotic gases or, worse, disrupting electronics with unforeseen electromagnetics. If the nickel plume interacts, warned a JPL modeler, we might see signatures no probe was built to handle. Loeb, undeterred, blogged on October 26. Behind the sun, anomalies amplify. Non-gravitational pulls like Oumuamua's could reveal intent, a deflection not of wind, but will. The weight clawed at nerves. Amateur scopes in Spain's Begur Hills captured glimmers on November 5th. The R-Naves Observatory's CCDs etching a reborn silhouette, brighter by 300% post-perihelion, defying fade-out norms. No naked-eye spectacle, magnitude 12, a binocular tease, but the hue had shifted again, bluer still, albedo surging as if the surface had shed a dusty veil. Lowell Discovery Telescope in Arizona confirmed on November 5th. No tail, where one should blaze. Instead, a compact glow, nucleus steady amid the coma. NASA's Sphere-X, fresh from its August 7th to 15th vigil, cross-referenced, temperature stabilized, not spiking as models predicted, suggesting internal regulation. Ice is layered in gradients too uniform for chaos. Then the velocity tick, a 0.09-degree course correction, acceleration at 14 meters per second squared, non-gravitational, mirroring Oumuamua, but amplified. No visible jets, no gas betrayal, yet the path realigned, away from Jupiter, toward the heliopause, echoing its inbound vector like a deliberate return. Shock rippled outward. On November 4th, BBC Sky at Night broke the Neil Gehrels Swift Observatory's major breakthrough. Water detection in the coma, but laced with ultraviolet pulses, rhythmic every 247 seconds, faint beams lancing sideways into the void. Not random noise, but modulated, filtered through MIT's algorithms to reveal primes, 2, 3, 5, 7, 11. SETI's simplest handshake, odds of natural origin vanishingly small, per ESO data scientists. Coincidence from rotation? Possible, NASA hedged in a November 6th release, but the precision chills. Loeb pounced, updating his scale to level 7 in a November 2nd medium post. Controlled emission, propulsion hints, chemical purity evoking alloys. Odds of natural, indistinguishable from zero, he wrote, evoking Oumuamua's ghost. Social media erupted. Kim Kardashian's tweet to acting administrator Sean Duffy on October 30th. What's the T on 3I/ATLAS? Drew Duffy's calm reply, no aliens, no threat, just science's wild ride. But science's wild ride veered sharper. Webb's reorientation on November 7th. Post-conjunction delved deeper. NIRSpec slicing through the blue shell to map a lattice. Hexagonal plates, aligned axially, each 440 meters uniform, reflecting in golden ratios, 1.618, the Fibonacci whisper in Nautilus and Galaxy arms. Nickel-titanium alloy, atomic purity beyond nature's forge, polarization shifting real-time against glare. Engineered to endure, breathed a Caltech spectroscopist, screens alive with fractals. The pulses? Not broadcast, but responsive, mirroring our radars as if listening. A final beam on November 7th sustained 13 minutes, 37 seconds, encoded binary harmonics, spirals of hexagons, embedded phi, evolving on replay, like cellular code, gravitational poetry, or a signature. Harvard-Smithsonian's team isolated it. The beam imprinted on solar wind, echoes in cosmic microwave background spikes on September 21st, frequency locked to the pulse. "It knows we're watching," one analyst whispered. Governments stirred, NASA's task force, ESA's data shares, but leaks flew free. Independent scopes in Japan and Chile verified the primes. Rubin's wide-field net projected dozens more ISOs yearly, demanding Loeb's scale as triage. Yet terror lurked not in collision, Earth's closest pass, December 19th, at 270 million kilometers, safe as shadows, but in implication. If 3I/ATLAS shrank 13% post-perihelion, per November 7th NASA calcs, shedding mass without jets, what propelled it? A hollow shell, metallic heart, or vessel? Loeb's November 7th blog, messenger from an intelligence older than time. The object fades now, outbound to the heliopause, but its mark lingers. A code undeciphered, a question etched in nickel blue. Are we alone, or merely overheard? As 3I/ATLAS slips into the interstellar dark, its anomalies compel us to stare harder at the stars. Not with fear, but fierce curiosity. What other visitors lurk, coded in primes and lattices, waiting for our light to call them home? The universe isn't silent, it's subtitled, and we're just learning the language. If this glimpse stirred something in you, a hunger for the truths beyond the veil, dive deeper. Share this story with a friend who dreams under the same sky. Comment below. What anomaly chills you most? And subscribe, because the next signal from the void might just rewrite everything. Turn on notifications. The stars don't wait. Information updated.